So guys, now continuing with the implementation of thread pooling. So now let us start with the implementation of stage 2 and stage 3. So stage 2 is all about executing applications thread function on applications argument. As you can see that this is the API and the second argument is the application specific function to be performed on an application specific data, which is the third argument, right? So stage 2 is all about executing this particular function on this data, right? So we need to figure out a way how thread can know that it has to execute stage 3 function also immediately after stage 2 has been completed, right? This is what we have discussed. After executing the step number 4, and step number 5 is actually not a step, it just represents the finish of the application task. The thread which is doing the application work has to execute the step number 6 to park itself in the thread pool, right? So it simply means that a thread needs to have a knowledge that it has to park itself into the thread pool after it has executed stage 2 function, right? So there should be some data structure which stores the info regarding how thread should execute through stages, right? So we need to provide the information to the execution unit, that is the thread, which controls the behavior of the thread during its execution. We need to figure out a way how thread can know that it has to park himself or herself to the thread pool after it has completed the application's task. So on the right hand side, such a data structure is defined. If you notice that this data structure consists of two parts, the first part stores the function and the data which represents the stage 2 work, right? Work is nothing but work is equal to function plus argument, right? So this thread stage 2 function is nothing but it is same as this thread function which was provided by the application. And this stage 2 argument is nothing but it is a pointer to the data which was provided by the application, right? So the first two members of this data structure represents nothing but stage 2 work, whereas the next three members in this data structure represents the stage 3 work, right? So you can see that this is a pointer to the function which represents the stage 3 work, and this function we have already implemented as a part of helper APIs, right? And if you notice that this function accepted two arguments, the pointer to the thread pool and the thread which needs to be parked into the thread pool, right? So remaining two members of this data structure holds the addresses to the thread pool and the thread which would be supplied as an argument to this thread stage 3 function, right? So if you notice, this entire data structure contains the information regarding stage 2 function and the stage 2 data, as well as stage 3 function as well as stage 3 data, right? So now the next challenge is how we can use this data structure to guide the execution of our thread through stage 2 and stage 3, right? So guys, now let us start with the implementation of this API thread pool dispatch thread. I'm intentionally going a little bit slow because we are discussing the critical part of the implementation of thread pooling. Thread pool data structure is one of the classical data structure which involves the thread management. So I'm going a little bit slow so that you guys can understand and assimilate the design and implementation of such a data structure. And of course, there is not a single way of designing and implementing thread pooling, but what I'm discussing is one of the ways of implementing thread pools. If you can implement it in some other way, then you are most welcome to do so, right? The end goal should be same, that the application must not create or destroy the threads during its lifetime. So to start with the implementation of this API thread pool dispatch thread, so the very first thing that we need to do is to fetch the thread from the thread pool, right? So we will use the API thread pool get thread, and it might be possible that the thread pool may not have any threads, right? Because all the threads have already been dispatched to do application specific work. So here we are simply placing a check that if there is no thread available in the thread pool, we can't perform the application work, right? So we simply return. So proceeding forward beyond line number 208 means that we have successfully obtained the thread from the thread pool. Now it's a time to malloc this data structure and fill up the members of these data structures. So now let us see how we can do that. So first of all, we will going to fetch this data structure from the thread argument. So it simply means that the thread argument will going to store the pointer to this thread execution data. The reason is that this information stores the information regarding how thread has to be executed, right? So in case if the thread is being fetched from the first time from the thread pool, then this thread execution data would going to be null. And in that case, we will going to malloc it, right? When we will be completing the entire thread pooling data structure, you will be able to stitch together the bits and pieces of the entire design and understand that how things are actually working end to end. So for now, just understand that we will going to store this thread execution data as a thread argument, right? Now the next thing that we will going to do is to fill up the data members of this thread execution data object. And if you notice, we already have all the information available to fill all the members of this thread execution object. So you can see that thread execution data thread stage 2 function is the application specific function which we need to perform in stage 2. And we already have available the application specific data to be processed, right? Now coming to the stage 3 parameters, the thread stage 3 function we have already implemented as a helper API, right? And we already know that stage 3 needs to be executed on a thread pool and the thread itself. So we already have all the information available, and this is how we fill up all the data members of this thread execution data object, right? In totality, you can see that thread execution data object is nothing but it stores the information how stage 2 and stage 3 have to be executed. That is the functions along with their arguments.